covered in Tekla Structure Designer. The one-base slabs we cannot design in Tekla Structure Designer. So if you want to really design the slab, right, then you have to carry out the finite element analysis. Okay. So if you want to do the design, then you have to do the finite element analysis, right? So if someone asks, so I am going to cover today flat slab, right? So flat slab, you can do the finite element analysis, then you can do the design. But flat slab design is a very big topic. It cannot be explained within 2 weeks, 2 hours time. So what I am going to do is I am just going to cover modeling only, how to model in Tekla Structure Designer and how to carry out the design. I presume you guys already know the theory, how to do the flat slab design manually, or we're using to 2D frame analysis method, right? So when you consider flat slab, right, traditional way we do the 2D equivalent frame analysis. It's called equivalent frame analysis, right? So there some common wording is column strip and middle strip, right? So I believe you all of you are familiar all these terminology. So all of you know how to do the design using equivalent frame methods, right? So today I'm going to discuss how to design the flat slab using finite element analysis, right? Okay, so let's do the modeling first, right? So what I'm going to do is, okay, now I have the first story, second story, and third story, right? So I am going to extend my slab, column and wall to fourth story. Then we can do the modeling at the first story. In order to model the first story, right? First, what I want to do is I have to create the level. So before that, I serve as another file. So I serve model only. Today is a class 6. So I serve as a class 6. Okay. So now I'm going to do the modeling. First step is we had to add the levels. So let's go to the modeling, model menu, go to the construction levels and add the level above. Okay. So this level I'm going to call as story 4. Oh, why? What's the problem? Why so slow? Give me a minute. Let me check my internet connection. Oh, okay. Now I think okay. Okay. So let's start. Okay. Story for float for high. I keep it 4 meter. Okay. Then let's go to the modeling. So okay. Sorry, my mistake is I make as a unique. So it's not a unique, right? Sorry, it's a unique flow. It's not a copy from the first story. So I go to the level 4. So basically delete all this one. It's strongly copied. I delete everyone thing. Okay. So okay. So now I go to the foundation level. I select all the columns and walls, right? So go to the property because just I want to extend the column and wall. So the easy way is we go to the property and make the top level as a 4 story. Then now you go and see 3D view. All columns are extended. Wall not extended, right? All columns are extended. Okay. So I'm going to select the wall also. So wall also I extend up till the for level 4. Right. So I believe most of you know about the flat slab, right? Okay. The normally in the flat slab, right? We provide the column cat or drop panel, right? So there's no any beams. So flat slab means slab with the rope panel. If we go without rope panel, that's one called as a flat plate. But that's if you want a flat plate, right? You want a very thick slab. So I am going to cover the flat slab first. So flat plate very easy. Actually, flat slab is more difficult thing. So I cover the flat slab first, right? So in order to do the flat slab, first we had to know how much the slab thickness and how much rope panel thickness we require. Let's see the grill lines and the spacing of the column. So I measure the spacing of the column. How much? Go to model.
9 meter.
Let me measure it. It's okay. I can remember how the dimension. Okay, 9 meter by 6 meter. Okay, so it's a 9 meter by 6 meter grid. So what I'm going to do is uh, my grid. Okay, normally flat slab is rule of thumb. Rub panel size is 1/3 of the span. Okay, so in this way, x direction, my rope size is 3 meter. Y direction, my rope size is 2 meter. Okay, thickness, right? Based on my rule of thumb, 250 thickness is sufficient this area. Okay, so if slab thickness is 250, normally rope thickness is around 1.75 to 2 times of the slab thickness. So I go with 4.450 thick rope panel. So my rope size is 2 meter by 3 meter by 450 mm thick. Okay, so generally rope panel we want the overhang, right? Otherwise, in the punching design may not work. So what I'm going to do is I'm going to extend the slab by 2 meter. So first I am going to draw the construction line, right? So to draw the construction line, go to the parallel, quick parallel, click the grid line, and we take 2 meter offset. Okay, similar way, taking the offset all four sides. I'm just preparing the all grid lines. It's unnecessary line, wrongly do it. So I delete these lines. Okay. So I extend this edge. Oh, sorry. This is just a second line. If you want, you can delete later on. Okay. So now let's go and draw the slab. Okay. In order to, okay, first what we want to do is in the flat slab modeling, you had to draw the slab first. You could not draw the rope panel. So first you had to draw the slab, then only you can draw the rope panel. So drawing the slab same as so row the slab on the beam. Go to the slab, right? Click the drop down and find flat slab. Okay. Now you can draw the slab, flat slab, right? Just click. Just click and draw. You see the thickness. Okay, sorry, I haven't checked the thickness, so I delete first. I go back. I had to set up the properties. So let's see one by one. I want to include the diaphragm, right? Overall depth, right? Later we modify it, right? Overall depth, I make it 250, right? Flat slab is a two-way distribution. Automatically is a two-way distribution, right? Flat slab. Analysis parameter. If you want to analyze the orthotropic, then you can do it. But concrete we can consider as isotropic. So I don't include these parameters. Okay, deflection parameters. Okay, this is a big topic. I don't want to cover today. In the flat slab, the deflection checking is a very big topic, right? It's not like a simple thing because you had to consider the creep effect to calculate the long-term deflection. So it's a big topic. So today I'm going to cover only the strength design. So just click, then you can create a slab. So you are creating a slab one by one, right? This is one way you can do it, or you can modify it. So I do it this one first. Let us show you how we can modify it. Okay. So if you want to modify, what you can do is just click the slab. Now you can see the knot, right? So click on the knot, right? You can modify it like this. So it's automatically snapping. So you can just modify these slabs. Okay. Similar way you can modify all the slab. So let me finish the slab first. Later we can go on model the rope panel. If you want, you can just draw one panel, then you can extend it. But to me, that is not a good idea. If normally I follow this way, because if you want to delete locally and change the slab, then you don't need to delete entire area. So if you row small slab, then it's easy to handle, but it's up to you to decide. If you want, you can row the say one slab, then you can extend your slab. Okay, so let me finish faster. Okay, okay. Okay, I have finished the slab. So this is my uh, slab footprint, right? Now I am going to row the rope panel. Rope panel, okay, you look at the slab tab, right? Go on top, right? So click on the rope down, then you can see column rope, slab opening, slab overhang. Okay, slab opening we haven't done last time, but if you want, I can try today. Actually, slab opening is very simple. Just give the size and click it, then you can make the opening. So later we can create a simple opening. So first I'm going to do row panel. So click on the row panel, right? Now in the property box, you can set up the sizes, right? First depth, thickness, right? I say 450. I'm going to write 450 first, right? Breadth is a extra direction normally, right? So I make it 3 meter, 3000. Depth is by direction. I make it 2 meter. Okay, I leave it 2 meter. So now come and click on the center of the column. Prop panel normally calculate based on the center of the column, right? So click on the center of the column. So now you see already place it. So go and click everywhere, right? You can drag drop also. Yeah. Because prop panel you can see you can draw only at the column location. It cannot be drawn at the area. So you can just drag and drop it. Okay. So it's look okay. Okay. So we have done the rock panel. If you want, we can go and see in 3D. See in 3D, right? So if you want to see more, we can go and see the section also. Let's go and see frame one, right? So look at the rock panel. So this is a rock panel, right? Okay. Okay. So it's look okay. Now we have finished our rock panel modeling. So let's go and apply the loading. So I'm going to apply the same load as below. How much load we applied last time? Let's see. Impose load how much? 3 kPa. Okay. So we apply the same load here, 3 kPa. So I am going to apply the slab loading. So in order to apply slab loading, first we got to go to the load menu, right? So select the load case. So here impose load, right? Select the slab load, right? Set up the load here. It's already 5 kPa. So click on the slab. So entire slab is selected because we use a slab loading. So same is apply the load entire slab. That means same type of slab is already applied. Okay. Now let's go and select the dead loads. So dead load, I am going to apply only the finishes. So I decide 1.2 kPa dead loads. So apply 1.2 dead loads, then apply the service load. Services last time I decided 0.5 kPa, right? So I apply 0.5 kPa. Okay. So loading is done. Right. So now let's go and see our bill loads because bill load last time we apply only up to uh, third story, right? So let's go and see the bill load, right? So to bill loads, loading, decompose load. I think we have to run it, otherwise we cannot see the bill load. Okay. So let's run and modify bill load. So I quickly run. After we can modify the bill load. Okay. Oh, we can modify it. Okay, I think we had to reapply it, otherwise it doesn't work. Okay, never mind. Okay, so let's go to the wind. Right. So apply below. So 8 meter, 4 meter, 0. So 0.65. Okay. So now analyze. Okay. So is become double, is it? Okay. 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 So I already adjust the bin loads, right? So okay, let's go and do the flash lab design now. Okay, so in order to do the flash lab design, first I had to go to the plan, right? So level 4 plan. So one important parameter we had is check before go to the flash lab design. As I said earlier, flash lab is a finite element analysis. So in order to do the finite element analysis, what first we want to do is we had to mesh the slab, right? Go to the slab level, right, for story. And here you in the property, you can see mesh two-way slab. So we are meshing all two-way slabs at the level 4, right? If you go to level 2, we are not meshing because we don't have any two-way slab, all are one-way slab. See, we are not meshing. But here is a two-way slab. You know that all slabs we define as a two-way slab. Remember, we define all slab as a two-way slab. That slab is automatically two-way slab. So now what we are doing is we are meshing the slab, right? So we are meshing the slab. So if we tick this one, software automatically know where it need to be meshed before do the analysis. Okay, now let's go and do the analysis. It take long time because it's running the flat slab analysis. Okay, now analysis completed. So we go and see the results for the combinations. So you can select any combination. I just select one combination, right? Okay, so now let's see the results. Okay, flat slab is a 2D, right? 2D results. Slab results is a 2D, right? Beam results and column results are 1D. This is a 2D result. So it's under 2D results tab, right? You can see the results. Okay. So here, right, if you click that drop down, you can see many properties, many parameters. MDX top, that means moment X direction top, right? So if you want to understand clearly, I wrote the sign convention here. So this is a X, global X, this is a global Y, right? So this one called MY, moment about X axis called MY, moment about Y axis called MX. Okay, so now let's go and understand the results. So I click on MTX. Is this one is the top. This software, the good thing is it can show the results top and bottom separately. Some software I cannot show. So this software good thing you can see the MN, MX and Y separately. If you want to see both together, then you can go down and click MX and Y. Okay, now I click the MX first, right? So now you can see the bending moment diagram, second tour, right? So you see moment is this way, varying from here to here, right? So uh, negative means sacking, positive means cocking, right? So if you look at here, right, the mid span is sacking moment. At the column is a cocking moment. right? Later I cut this one strip here and show the bending moment diagram. Later I'll show you clearly. So now in the contour itself, you can understand how bending moment is transferring, varying, right? From here to here, how it's varying. So it's clear to say moment is this way. So that is mx. So m by, how is the m by? So moment is this way, right? So now you can understand, right? This is a normally this one we call as a column strip. This one we call as a middle strip, right? So this is a fundamental plus step design. Okay. So when you after do the analysis, actually you have to look at the moment contour and shear force contour, because sometimes we rely on the strip design. Even though you rely on the strip design, better take a look at the moment contour, because if there are an issue, then you can understand. If your analysis is not right, then you can see some unrealistic moment contour. Then you can find out, yeah, there's some mistake. Then you can go and do the analysis again. Okay, so this moment control look okay. So I go ahead. So now you understand the sign convention, right? X and Y. Also, negative mean sucking moment, positive mean cocking moment. Okay. So let's go and see the more results. Okay, sigma x, sigma y, you familiar, right? Sigma x is axial stress, x direction, sigma y is axial stress, y direction. We don't need axial stress anyway, right? Basically, we want bending moment and shear forces, right? Shear forces is tau x, y, and tau yx. Two so, sorry, this one is tau xy is only one, so not two, right? Only one. Top and bottom, showing top and bottom separately, right? Okay. So if you want to see top, you can click here, right? See, right? So you can see, okay, how much shear force maximum we can allow in the slab design. Maximum, right? The concrete maximum, how much is a maximum concrete design we can, maximum concrete shear we can allow? It's around 5 MPa, right? So let's say if exceed 5 MPa, straight away we know our slab thickness not sufficient. Then you had to increase your slab thickness, right? This okay. This is not the exact design. Is now I'm talking about the rough idea, right? After analysis, how to see the results, right? So now you see this area is a high stress area. You can see high shear forces here. Reason is we don't have any rock panel here. Surrounding this area, no rock panel, right? So this ultimately we understand, yes, there's a peak stresses because there's no rock panel, right? So it's reasonable. So similarly, go and see the bottom, right? So bottom C, bottom's very low, but the localized area, right? This area slightly active by MPa, right? I leave it. Okay. If you want, you can thicken the slab around this wall area, then you can avoid this problem, right? So this local area stress is exceeding, right? So the local area actually you can do the strengthening and avoid this problem. Okay. Outside actually is okay, no issues. Okay. Right. So if you want to further investigate this result, right, you can check mx top separately. Okay. Now see, outside this area, right, zero means, right, it's a sacking moment, right? It doesn't mean there's no moment. There's a moment, but the sacking moment. This contour purely showing you only the cocking moment, top moment, right? Cocking moment. I call cocking, right? Or the moment of the top surface, right? So you see, the maximum moment is 400, around 400 kilometer meter, right? But minimum is zero because it's the top. We are looking only the top. Okay. Similarly, you can see bottom. Now see, column all are zero because we are looking the bottom sacking moment. So now look at the sacking moment, right? So maximum sacking moment is 83 kilometer meter. Okay. Similarly, we go and see my same, right? So you can see the value, right? M by maximum 280, mx maximum how much? 400 plus, right? So it's reasonable because our grid is 9 by 6, right? So m by is automatically we know moment is low compared to mx, right? So similarly, you can see the bottom. Right. After see this one, right, you can quickly have the idea, right, how much is a maximum rebar, right? Let's say by direction bottom rebar, if you want to calculate quickly, 46 kilometer meter for 250 thick slab, right? 1 meter, 1 meter strip, 250 thick, 46 kilometer meter moment. So you can quickly calculate how much maximum rebar is required. This whole idea you want before go to the detailed design. Detailed design you can do faster, but you have to get the feel. Yeah, how much is rebar? Okay, normally when you do the design, slab design, importantly, what you want to do first is you can calculate how much is the minimum required rebar, 0.13 or 0.15%, right? So you have to calculate that one first, right? Later, you calculate how much is the maximum rebar you want it, and find out the location, which area I want the maximum. See here, this area only I want the maximum. These areas I don't need maximum. So you can identify a certain area, let's say 27 or 30 and 46. You can do the two calculations. See, okay, my rebar minimum, let's say H13, right? Sorry, so long as you use 12 diameter, H12, 200 spacing, minimum rebar. But certain location, maximum area, I want H12, 100 spacing. Right, most of the area I want H12, 150. Then you can decide how to detail your slab, right? So this is a way you had to look at the results, right? From the results, you had to get the quick feel how to detail the slab. Okay, so now let's go and see bottom, top bottom. Okay, here you see how much maximum, 83 maximum here, but this one is only 56, 50, 56, right? These two, right? So now you know how to calculate this one, right? So your stresses are okay, moments are reasonable, shear stresses are okay. So we don't need to increase the slab thickness, right? Okay, so if you want to see deflection, you come and click here, set deflection how much, right? So automatically, even though you select this combination, right, automatically show only the service stress. If you have doubt, you can go and check it, go to the load menu, combination, right? If you see this combination, right, you can see service, right? Service is 1. This is a permanent SLS quasi permanent loads, right? So if you want to do the long term defect analysis, then you can use this combination. But now I look in the short term service, so it's a one, all are one factor. So even though you select this combination, deflection is showing the service deflection. So look at here. So this deflection is quite high. It's not reasonable, right? So normally flat slab, right? If your deflection is more than 30, 40 mm, so normal rule of thumb is span over 250. So if your deflection is more than that, then you had to increase the thickness or you had to increase the rebar and so on, right? But these are not reasonable. If you want to increase the thickness, you can increase the thickness this span if you want. Okay. So I don't spend the time here. We can go ahead. Okay, we go to the results. Okay, so deflection you can see here, right? So I want to spend the more time on the strip. Okay, so I click the maybe MX. Okay, so look at the MX. This is MX, right? Now I am going to do the design. I am going to design this one, right? So there's a many way to design. So, okay, based on this diagram also you can design it. Based on this control you can design it, but that's not the appropriate way. Normal way is we do the strip method, right? So then how to decide the width of the strip, right? Slab, right? Generally we design for 1 meter, but flat slab, that's not correct, right? So we decide, let's say I encounter row one strip along the center of the column, right? What is the width of the what is the width of the strip, right? There are many methods, right? Generally agreed method is 1/3 on the, okay. That's why you can understand the concept of column strip and middle strip. Right. If you open the all BS code, I think now Eurocode we don't have this guide, but if you open the all BS code 8110, you can see the guide how to define the middle strip and column strip, right? So generally column strip we take until the rope panel, right? So our reference size is 1/3 of the span, then we can consider column strip until the rope panel. But if you want, you can go until half of the span, right? There's a flexibility in the code, allow it, right? So 1/3 to half, you can go ahead, right? So now I decide 1/3. So rope panel size 2 meter. So I go 2 meter, right? So uh, I'm going to draw center, so my panel width, sorry, strip width is 2 meter. So first, what we want to do is we have to draw the strip. So see here, strip results. Click, right? Now you have to draw the strip. So pick at the point here. Before that, you had to set up the property. So see, these are already 2 meters, starting with an end with 2 meters. Actually, you can vary. You can draw the strip with varying width. In case your slab is irregular, then you can change these parameters. But our one is regular, right? So I go 2 meter. So I start the almost center, right? So go until the end. Okay. Now go and click strip results. So actually this is a deflection diagram. So right click on this strip, right? Go to the open strip diagram view. Okay. Okay. Now you can see like our beam bending moment diagram and surface diagram. Now you can see strip results, right? See, if you want the more results, you can move this arrow and see actual. So when you move this arrow, these all texts are changing. Can you see? All texts are changing when you move it, right? You can change your load combinations also, right? Also, if you want, you can go to the envelope, right? You can see envelope results, right? So see envelope bending moment diagram, and below is a required rebar. So required rebar automatically calculate, right? So maximum rebar is 1907. Okay. So now you know how to detail this area, right? Top bottom bar also you know, top bar also you know, right? So if you want to do the curtailment, you can bring here and see how much rebar here we need here. It's around 1760. This one 1907. So no much different. If you want, you can provide the same rebar for both top panel, right? Look at the mid. Make is 1460 here. If you want, you can reduce a rebar here. Okay. Okay. So if you want to see the deflection, then you have to select the load combination, right? You can select any combination. Then you can look at the deflection diagram, right? Deflection automatically you can see that the maximum deflection is 47 mm, right? So generally this one not acceptable. There's a way to control it. You can add the rebar and so on, right? Or you can increase the slab thickness. Right? So basically it's showing all the results, right? So this is an easy way to do the design. Right? Instead of just relying on the contour, this is an easy way to do it, right? Right? It's more, you can design the river more uniformly, right? If you look at the contour, right? So, son, you have to decide how to average within this area. You see, this moment is varying from 370 to 230, right? 230. Okay. If you want to see the exact results, right? You bring your cursor, right? You can see below. You see how much MX 341, right? So go to the or the far end, how much the almost MX is 63 only. So if you bring here, it's around max 291. So it's varying quickly, right? So it's not easy to calculate, right? So if you go this method, strip method, then you can design for it, right? So if you want to share, okay, that how to calculate the moment, how this one calculating moment is a right. So it's go with the average method. If you don't, if you are not happy with the average method, you can change this method. Actually, you can go with the maximum or center line. Center lines, yeah, maximum actually is not, average is actually okay. Yeah, within the rod panel, you can average the moment, right? Okay. So similarly, you can draw another strip, right? Actually, you can draw many strip, if you, right? So what you can, I am going to draw another strip here, right? So another strip here. So I finish the X strip first. Is all equal anyway. I leave it first. So I want to do the middle strip also. First, I finish the column strip, right? Okay, if you want, I can draw this one. So you can see all the results. Generally, we don't rely on the moment contour. We do the strip. We cut the strip and see how much is the average moment. But sometimes we cannot just rely on the strip also, especially when your slab is regular, then you have to look in the moment contour as well. Okay, now I am going to draw the middle strip, right? So it's at we say 2 meter, right? The column strip 2 meter, right? Remain is 4 meter, so you can cut the another 4 meter section here as a middle strip. So I make it 4 meter, right? So you have to pick up the almost center point here, right? So actually you can see the coordinate, right? So if you see this coordinate, then you can calculate it and you can pick up the point almost there. So my point is not correct, so I pick it slightly below. It's almost okay. Okay, so now let's go and see the middle strip. Okay, so see middle strip, right? Okay, it's calculate the maximum and minimum rebar for you. You see, bottom rebar is high. Yes, middle strip our sacking moment is high compared to hooking moment. So sacking moment is high, so its rebar is high. Okay, right. If you want, you can go and see the envelope and you calculate based on the envelope, right? How much is the envelope? Okay. Similarly, if you want, you can cut more middle stuff here, right? So also you can see other graph, other strip results, right? How slow, right? So you can check one by one. So I am going to check the envelope. So roughly we know how much rebar is to be required, right? Okay. So now you know how to calculate the rebar, right? Okay. Similarly, X direction, right? You can draw the strip Y direction, right? So I got MY. Maybe I can cut one strip only. I no need to spend more time here. So let me cut one strip first because today I want to finish my foundation design and go back to Revit. Oh, here I want to explain. Here my panel width is 3 meter, right? So I have to change to 3 meter. Okay, okay. Some engineer has a different opinion on the column strip and middle strip, right? It's your own decision, right? So I just following the all BS standards, right? Oh, sorry. because some engineer is still following the equivalent area. So for column is strip and middle strip is the same width. That's not also correct. I don't say it's wrong. Sorry. Let me see the envelope results. Okay. So here automatically we know, right? So almost our required rebar is half of the x direction, right? Because x-axis span is 9 meter. This is only 6 meter. So automatically our rebar is half of the x direction rebar. Okay. So now you know how to calculate the rebar. After you calculate on rebar, you can detail your slab. Okay. Okay. Now I'm going to do another way, right? Okay. Actually, this way I don't recommend it, right? Flat slab actually you have to do the design based on the strip and contour method. But this software has a facility; it can automatically do the design, but it's based on the contour results. Okay. Based on the contour result. So go to the design under the slab, design slab. So it's calculate the rebar for you. Also, it's saying this area is failed. Okay, we go and see why is failed. Okay, so this area pass. So we click on one of the slab panel, right click, go to the check panel slab, oh, slab, sorry, check panel. So now you can see the summary rebar, what is calculated, right? X direction, Y direction, top and bottom, correct? So if you want to see the detailed design, right, you can go and see here. Okay, actually you can enlarge all these one. See, you can see the results. All the results you can see moment, how much is a moment and how much is a provided rebar. Okay, so it's okay. So now let's go and see why is this slab is failed. Go to check. Okay, so reinforcement detail is failed. Okay, top X failed. So for it is a moment capacity. So moment capacity failed. Oh, give me a minute. Sorry, it's a urgent call. I want to attend it. Okay, okay. So let's see why is failed. Okay. Now let's see the design, right? So okay, see here, right? More required rebar is this one, but provided rebar is this one, right? Okay. The rebar is very heavy. That's why the software did not provide the rebar automatically, right? But you see, based on our strip method, right? Our rebar is much lighter than this one. The reason is take the average, but this one is designed for peak moment, right? So if you go with the automated design, this is a disadvantages, right? You pick at the peak moment and design for it. So sometimes you have to overprovide the rebar. That's why normally not recommend to go with the automated design, right? So it's always recommended to go with the strip method. Okay. Okay. So one more thing we can do here, right? Okay. So this one we call as a patch design or column patch, right? Let's say now you see this area. We know this area is a moment high, right? So the software has a one feature. So it's one called a patch. So if we have a peak moment, we can create the patch and then we can design the patch, right? So it's say they are saying that if you create a patch, right, then you can do the average, you can calculate the average moment and do the calculation accordingly. But normally I don't rely on all this one. I do the strip method, but for illustration purpose, I'm going to explain this patch design. So first what we want to do is we have to create the patches. So yeah, like a row panel, just draw the patch, right? So click here, click. Okay. So we finish the patch, then we design the patch, right? It's still failing. The reason is the same, right? So when the peak moments very high. Okay, right. So normally you do your own design. After I do the analysis, you do the design based on the stream method or contour method, right? So another feature is scarce is punching shear check, right? So punching shear check quite useful. You can do the check faster. So it's very fast. You can select the area, then you can do the check automatically. So similarly, patching the patch, right? So you can select the area, just pick up the column. So okay, it's automatically pick up the punching area first, right? Now it's drawing the punching perimeter, right? So after that we can analyze. Okay, so now do the punching design. Okay, so punching design done. So let's go and see whether we need any punching drilling or not. So select this area, select the column, right? Select the column, right click, right? Go to the punching, check punching shear, right? Look at the summary. So we don't need any punching shear. Punching shearing not necessary for this column. So this is the H column. Look at the uh, center column. Generally, H column and corner column are critical. Generally, right? Center column shouldn't be an issue, right? So let's go and see the H column. Okay. So it's basically it's okay, right? Right. Okay. So in the drawing wise, right? if you want, you can export the drawings, but you know the design, right? Design is based on the panel design, right? So yeah, if you want, I can export the rebar drawing here. Right. Okay. It's showing the rebar on the panel and the middle strip, right? You see middle strip, right? This way existing 200, this way is 10 100 bottom. The top existing 150 and H 12 150, right? The inside the rope panel, right? This is a rebar. It is inside the rope panel. Okay. So this is the rebar inside the rope panel. So these are heavy rebar, right? These are heavy rebar, right? So okay. So if you want, you can modify this rebar. But this drawing actually not useful, right? We don't detail like this, right? This is just an indication only. Then you can modify your detail based on your own standard. Okay, so that's all is a flat slab design. I stopped the analysis and design here. Now I'm going to design footing, flat footing. Okay, so I go to the foundation levels, right? So in the model, right? So if you want to do the footing design, right? First we had to finish the analysis, right? The foundation loading must be ready for the foundation design, right? So let's go to the foundation, right? So under isolated foundation, right? Under isolated foundation, fat base for the column and strip base for the wall, right? I select the fat base, right? So here, right, you can ask software to calculate the sizes, or you can select your sizes and do the analysis. I allow software to do the sizes, automated sizes, right? Automatically calculated. So what I am going to define only the soil parameters, right? So this one I just leave it, right? So I am going to define the soil parameter only, right? So right, structural parameters, right? Bearing capacity, right? So let's say my soil is for the 400 kPa, right? Your technical capacity soil is this is a combination 1 and 2 in EC7 200. A1 is a DSE1 and DSE2, right? So surcharge, if you have any surcharge, then you can add it. Just ignore it. If you have any permanent surcharge, you can add it. Everything you can add here, but I ignore it. So now I go and click. I see this is a initially is assume as a 1.8 meter by 1.8 meter thick fat bare footing. Later is calculate based on the requirements. So just click, right? You can drag and drop it. You can select multiple columns together. Okay. Okay. So for walls, I create a strip footing, same parameters, 400 and 200. This is my assumption actually. You had to calculate the bearing pressure actually based on your uh, own soil conditions. Okay, here is a width, right? So width, what's the width of the foundation, right? And the straight footing, right? I say it's 1.5 meter, right? Extension beyond the wall, right? So I want to extend 500 mm. Okay, so depth 450, I leave it. So I click here, click here, click here, click here. So in the foundation overlapping, we leave it first. So now I am going to design the foundation, right? So this is a design isolated foundation. You see the tab design isolated. So I click on the design file base. Sorry, design path base. Okay, we wait for the analysis. Okay. See, now the footing size is changed, right? So because we select the auto design, right? Select, it's already now it's unticked, but last time we select the auto design. So it's adjust the size according to the requirement, right? So if we bring the cursor near the footing, right, you can see the utilization like 0.99, 0.94. So it's close to one, all are close to one because it is designed according the required size, right? So if you want to see the size, bring the cursor here. So it's around 4.4 meter by 4.4 meter fat, right? That is 850, right? So, okay, this is just an initial design, right? After this design, right, if you want to change, you see this cap is very small. So if you want to change, you can change this whole as a one strip footing. So it's strip footing, right? It's more economical to do the strip footing here instead of fat footing, right? So it's a or engineer decision, right? Based on this initial analysis, you can decide whether you want the strip footing or fat footing or raw foundation, right? Raw foundation actually totally different. Okay, if you want to do the raw foundation, you have to go to the mat. It's called as the raw and mat is the same meaning. So you have to go to the mat here. Okay, so you have to go to the mat foundation if you want to do the design. So for matte design, again, same as for flat slab design. You can do the punching, check and everything. So according to the, is same as a flat slab design. So I don't spend the time on that one. So now I think you have a general idea how to do the building design. So first how to model it, then how to carry the beam design, column design, bolt design, right? So if you have flat slab, you know how to do the flat slab design, right? So basically, you know how to export the results to AutoCAD 2D drawings, right? So finally, how you can do the fat footing design, right? So if you want a fat footing rebar, right? So you can right click here, right? Generate the drawing, same as column and beam. Okay, so it's has given the footing, right? Now you see footing. See here, it's so only the bottom rebar. Why it's not showing the top rebar, right? Generally, fat footing we don't need the top rebar generally, but is normal practice we provide the minimum top rebar, right? So if you want to provide the minimum top rebar, what you want to do is when you go to the design, right side, so here you have to select the rebar, top rebar. So here see top rebar type, we select none, right? You can provide the loose rebar or mesh, Up to you to decide. So I select none, so that's why it did not give any rebar. If you want the rebar, then you can select here, then software automatically calculate the rebar for you, right? It's calculate the minimum rebar, right? So if you want the schedule for pad putting schedule, you can create it. You go to the row, right? So like a column beam, right? You can create a schedule for pad putting. Where is it? Column schedule. Oh, putting layout. Okay. So now you can see here, right? So the sizes, everything you can see here, right? If you, okay, before export it, if you want to group it, you can group it. You know how to do the grouping, right? Last week I explained, same as beam, you can do the grouping, then you can, because no, in general practice, we don't provide each column and different size, right? Normally we group it, right? Then you can group it before export. Then you can get a nice drawing, right? These all are individual plans. This is a rebar. You see in the schedule, right? This gives a size and rebar. What's a rebar, right? So if you don't want to show all this one, right, you can just show this one, right? This uh, schedule only. Okay. Okay. If you, it's very simple. If you practice one time, then you can understand easily. Okay, so now what I'm going to do is, uh, okay, my plan today is start the structural framing, but now I changed my mind. So next week, let's start a structural framing, right? So, so far I have covered how to do the modeling in Revit Success, how to do the modeling and design in Tekla Structural Designer, right? So now you can do the modeling in the Tekla, sorry, in the Revit. Also, you can do the modeling in Tekla Structural Design. Also, you know how to do the design and how to prepare the 2D drawing, right? So this topic I have covered all these 3 weeks, right? Next week I am going to start the example building, right? So rest of the weeks I am going to cover only that example building, right? So last week I'll start to do the some advanced topic. It's called family creation and so on. So some advanced topic in the Revit, right? So I don't come back to the Tekla Structure Designer anymore. So I'll come back Tekla Structure Designer only for analysis and design when we do the example building. Other than that, everything I am going to spend the time in the Revit. That means how to do the drawings and how to do the 3D modeling and prepare the construction drawings, right? That's my plan. So today, now I am going to explain how to export this model to Revit. Okay, so there's a different process, right? If you start the modeling in Revit, then you can export it to Tekla Structure Designer and do the analysis and design here, and again export to Revit. Okay, that's a one process, right? Or you can do other way. You start the Tekla Structure Designer first and do the modeling and do the design, right? Finish and design, then export to Revit, right? Your model automatically go there. But this model, you capture only structure element, right? If you have any other element, that one you have to model in Revit, right? So if you decide to do that way, then I'm going to explain to you how we can do it that one, right? So this is very easy process. Actually, it's simple, right? If you start Revit, right, there's a possibility to make many mistakes because Revit is a modeling software, right? So it cannot pick up the errors. But Tekla Structure Design is an analysis software, finite management software. It can easily pick up the errors, right? So you can do the modeling easy. So now I am going to export the Revit. So in order to export, you have to go to Beam integration menu, right? You have to look for Autodesk Revit export. Click, right? Now I am going to export the model. So I keep the point 0, 0, 0, right? So this one 0, 0 here, 0, 0, right? So I keep it same, right? Next. So which are element you want to export it, right? Analysis element you want to export or not. Analyze the results, right? Generally we don't need. In case if you want to document it, you can export it. Okay, now I click it, right? Okay, next. Then analyze results. What are the results you want to export? I want to export everything. So I click load cases, load combination, everything. I click OK. Send material. Okay. So actually here in the export name, you can change it. That I leave it first. Sometimes the problem is mapping. Tekla Saksa, they use one name, Revit, they use different name, right? Sometimes Tekla or Revit cannot recognize other software elements. In this case, we had to manually map it. That's why they leave it here. Let's say the Tekla Revit cannot understand this naming, then you can manually input here, right? Now at this moment I leave it. In case any problem, we come back and see. Okay, so now I had to select the, okay, here operation. I am going to export first time, right? So I click first time. I go and serve this one. I call this one is a class 5 uh, TST to TST to Revit. Okay, so I call A first, 5A underscore. Okay, it's my own naming convention. You can name anything. Okay, finish. Okay, now already exported. So now I am going for my Revit. So Revit 2023. I open the Revit. This one I can minimize it. So Revit, I open the new model. Okay, in the template, right? You have to choose Saksara template. Other template you cannot map it properly. So you must choose Saksara template. Otherwise you cannot import. Okay, now go to Tekla integration. Click integrator for Saksara designer. Right? So in this wizard, click next, right? Import model to Revit, right? Import model into Revit. First time we are doing. So click next, right? Now we have to choose a file. So our file is the class 5 and A, this one, right? TST to Revit. Open. Next. See, it's automatically recognize the elements. These are the elements exist in the model, right? So next, click next. See here, okay, this is a crucial steps. Mapping, Saksara column type, 1, no, not recognize 0, that means it recognize all. Saksara framing type, 3, not recognize 0, that means it's all recognized. Material, in the importer file has 2, not recognize 2, that means it don't recognize our materials. It don't recognize our concrete. So let's go and view the mapping. So in order to understand more, I click all this view mapping. So let's click next and see. Okay, rectangular, concrete rectangular column, right? Let's see. Imported element 460 by 600. X Revit name also 460 by 600. If you want, you can overwrite it if you want it, right? So I don't do now. Okay, this is actually correct. So next. Next one is a column. Sorry, beam. Right, we have 3 numbers here. Here also same size. Okay, it's fine. Then I leave it. Okay, material. Okay, import a file called C2530, but Revit name is different. So it's a is going to give this naming. Are you okay or not? If you want to change, you can click here and you can select the name. Actually, this is a Revit library. You can change it here. See, has in place C25. If you want to change it, right? But I don't want to change. I leave it this naming. To me, it's very easy to understand, right? So I leave it this one. Okay, finish. Let's wait until complete the uh, integration. Okay, there's a lot of warnings, so let's come for warning. Okay, first go one by one. Number of error 0, good. Number of warning 51. Okay, let's go and see one by one. Object created. So this amount of object created. Okay, see 10 grids, we have 10 grids, correct? 4 levels, yes, we have 4 levels. 84 columns, 84 beams, no bracing, 76 slabs, 4 walls, no truss. Object deleted, this is important. When you import, you have to see whether software delete any elements or not. Uh, Fortunately, it did not delete, so our integration quite okay. Object update is no, because this is the first time we are doing it, so no element update. This warning we know, we ignore it. Okay, we are happy about this integration, so we are happy about it, so issue. Problem here, look at the one warning, all are same warning. Highlighted flow overlap, failing marks and IDs, SI26, SI42. Okay, this slab overlap happened because of the flat slab. You remember how we draw the flat slab? We row the entire panel, then we row the row panel on top of it, right? So Tekla structural designer, that's a standard. That's the way we can row the row panel. But to drive it, two slabs are overlapping, right? So that's why Revit giving the warning. So to us is okay. We can allow this one because we already know this is overlapping. But for our modeling purpose, we have to allow it. So we allow that one. So this warning is okay. Okay. So I click it okay. So now see, in our Tekla Sakra designer, we have 4 level, but here only 2 level. The reason is after we open, automatically it had 2 level, right? We did not create any other levels, right? So we had to create the other level, then only we can map it, right? So when I import a file, right, it's automatically create inside. So we had to go and create in this view. So in order to create, go to the view, plan view, click the drop down, select the structure plan. Now you see story one missing. I give the reason later. The other plan, other levels already is there. So we select all, select all. Right now you can see here, right? So now let's go one elevation and see what is happening. See, level one and level two is already there, right? But foundation story 2 story 3 we created. Level 1 flow finish flow level 0, our level also 0. So it's map. So the Revit did not create any new levels, but this one is different level. That's why it created new levels. Okay, so I don't need level 2 now, so I delete it. Okay, I delete it. Level say 1, right? I want. So I select this one, uh, track it outside, right? I locate this one. So I know I can move all together, right? So to me it look very congested. So I am going to use the elbow, right? Okay. Look okay. If you want to change, you can change the name here. Now this one, unfortunately, we have to change manually. Okay. So now it's look okay, right? So now you see you have all the levels here. Or if you don't want analytical, you can delete it or you can rename it. If you want to rename it, you can go, you can right click on the label and rename it, right? Story one. Okay, now you see foundation level, story one, story two, story three, story four. So let's go and see foundation levels, right? So we have a foundation. Okay, you may ask me why the beam is showing. The reason is the level difference is very small, right? So if you go and see 3D, then you can understand, right? So this one I am going to shade it. So I shade the view. So now you see the differences, okay? See, almost touching, right? Like this we call a beam and this one, right? So that's why when you cut the section, when you cut the plan, we can see this beam. That's why this plan is showing this one. If you don't want to see this one, you can hide from this one view. You can hide it manually. Right, unfortunately we can see because of the, so if you don't, okay, in real case, right, normally this level is lower or we integrate together, right? So this example we didn't do it. So if you want to do it, you can go here and you can update the levels. Maybe I can make it 2 meter. So then I think cannot see. Yeah, now see, cannot see. Okay. So now let's see one by one, right? So let's examine how it's looking each elements, right? Because basically we are going to produce a drawing in Revit, right? Tekla success is just analysis software. Here we are going to produce a drawing. But in the model, you see, it's a look almost similar what we have done last time, right? Our modeling time, we have done this kind of the model, right? So it's looks similar, right? Okay. So let's click the column. Let's click the column, one column. See the property, 460 by 400 by 600 column. See the height and width, right? So it looks same, right? Right. So the important thing here after importer, right? You can see the parameters here. You see structural parameter. What is this? 12H16. This is a rebar, vertical rebar of the column. So it's export the rebar parameter here. The cover is exported, link exported, right? So all these parameters are exported, right? So let's click one beam. So I rotate this one. So this I click this beam. 3000 by 800. So go and see the properties 1000 width and 800. Correct. So we go and see the rebar. See rebar, bottom rebar, cover, link, side rebar, top rebar. It's showing everything. See, if you want to change it, you can change actually, right? So come here, okay? The analysis results. This exports are all the beam enforcers also. Okay, so in case if you want to design for connection or anything for steel beam, you can use these results, right? Also, it's export the marking, beam marking, right? You see beam marking, right? So later on you can mark this name on the plan. Right? Basically, it's exporting the most of the properties, the group and everything is exporting. So you don't need to do much work in the and modeling software. Most of the details already exported. Okay. My intention is I want to update something here, right? Then I want to export to Tekla Structural Designer and show you how we can integrate these two softwares, right? So I already done one changes, right? In the foundation changes, right? Foundation I already changed it. So now look at the wall, right? Always the problem is a wall and slab. Okay. So when you create the wall on the Tekla Structure Designer, this is a problems normally we encounter. See, base constraints foundation, offset is 0, right? Top constraints unconnected. That means it's a full height wall. So what is the height? 13 meter. Let's go and see the elevation. These are 2 meter. These are 12. Supposed to be how much? 14, right? But it's only 13. You see here is 13. This one, unfortunately, we had to do manually, right? So you had to careful on this one. You had to do manually this one. So I make it 14. Okay, let's go on the elevation see. Okay, let's look okay. Okay, another change I'm going to do is here last time we make it opening, right? Here we leave it opening, right? Now I want to provide the slab here, right? So we go to the structure and draw structural slab, right? Slab type, I select same as flat slab. Okay, see, we already have this whole naming here. You see, all this one is our naming, right? In the Tekla structure designer. So I'm going to use the same. So I'm going to use 250 flat slab. So I use a rectangle, observe, click here and click here, click OK. So this one delete. Okay, see this one. Okay, it's all so as a solid line, right? It's supposed to be a hidden line because our slab is top, right? The this one happen because it is overlapping. We draw it or as an overlap. That is a we it shows a warning, right? So what how we can avoid it is we can join these two slab. Basically, this is one slab. This is another slab, right? We can join together. So in order to join, right, you go to modify, join, click geometry join, click on the two geometries. So you see it's joined. So this one you can do one by one. Then you can get the nice drawing. Also, you can avoid the warning. It's joined together. This is a problem when you deal with two different software vendors, right? Sometimes we have these kind of the issues. So you have to understand what are the elements they are exporting. So what format they are exporting, right? So okay, one thing I want to show you. Okay, let me finish this one. So how we can identify what are the elements they are exporting and how what format they are exporting. Later I saw the document. If you have the doubts, then you can go and refer the document. Okay, all external okay, internal okay, it's not okay because you see internal slabs, right, is not okay. I saw you the problem. So let me finish this one first. So this one. So basically we are joining the all the slab and prop panel. Okay. So basically this four prop panel has a problem, right? This five has a problem because right here we cannot select it, right? So actually it's overlapping. That's why I cannot select. So in order to select this one, right, you go to here, height, reveal height element. So you can see here, right? This is a elements is a hider, right? So you can click, right? So actually it's not picking. Okay, never mind. Unguide. Oh, okay. Never mind. Let's go and guide this element. Then we can see. right in the view. Now you can see these lines, right? So let's join this one first. After that, go on and guide it. Let's guide this one also. So now I can select this one. So join. Okay. Basically all are okay. Okay. So now I go and guide the elements. So I guide this element. Sorry. And guide and guide. Okay. So now you can see all ripples are basically is joined together, right? Look okay, right? Our drawings. So I bring outside. Okay. So our drawing look okay, right? Okay. So what we did is we changed this one, right? We changed this one, right? So no- normally, right, when you do the change in Revit, you have to go to the 3D Analytica model and see, right? Right? This slabs actually is not there because we haven't created the analytical model. See? Analytical, this is analytical model, right? So we can create the slab here, right? So what we had last time we learned, right, how to create the analytical slab, right? So we go to the analyze, right? Analytical automation. Remember in the first second class, I explained how to create the analytical model in the Revit. So click here, select, select. Oh, sorry. Okay, but select. Why? Done. Okay, done. Now let's go and see. You see this one created. This panel is created, right? This panel is created. So if we want, we can do some other changes. Then we can you can understand more how powerful this one. Okay, I go to 3D. Okay, these all levels, right? Not correct. So I align these all levels basically. So we can go to the plan also. You can do it plan also. I select it with the 3D. Basically, I align all this beam to the slab level. Right? But it's good practice. You do the wall works in the plan because in 3D when you do the works, there's a possibility to make the mistakes, right? So the most of the modeling you try to do in plan. plan or section elevation. Don't try to do in 3D. Right now, go and see the plans. Right, you see plans. Right, first story plan. Right, these are showing the footing. Right, so if you want, you can guide it. Just right click and guide. Right, so then you don't see this one. Right, basically. So second story, see, right? So all are in green lines, right? It's look okay. So one more thing I'm going to I am going to change this beam size. Right? It's look very big. Last time I made a mistake, so I changed it to small beams. So second story also same. I changed to small beam, right? Third story, I changed to small beam. Okay. So uh, okay. Any other things? What other things we can change? Okay, let's say I want to add the slab inside here, right? So let me add the slab. Uh, Slab floor, access slab. This time I'm going to select one bay beam, one bay slab, 200 thick one bay slab. So choose a rectangle, right? From here to here, finish, right? Second story, then third story. Actually, you can copy also. Uh, I'm going to draw it, but you can copy same property. Choose the rectangle option. Click here. Okay. So we don't need this one. Delete. Second story also just delete this one. Go to the first story, right? So hide all this one unnecessary thing. Okay. The first story also I wrote the slab. Okay. So after create the slab, what we want to do is we want to make this one as a structure element. Okay. I save later on. So go to analytic. Oh, why? It's already running here. Okay. Select. I don't know why you cannot see now. Maybe the zoom run. Okay. So go to second story. Select. Run. Select. Go to third story. Select. Um, Closed. So now let's see the Analytica model. Close all this one not necessary. Foundation level also no need. Elevation no need. So let's see the Analytica model one more time, whether it's created or not. So, yeah, actually, the analytical model, right? The 3D, right? If you want to uh, look better, right? You click a section box, display. I see, just display. I don't know why. Okay, so go and see inside whether slab is there or not. Think slab is there. Hmm. Why? Oh, it's not created. Ah, it's created. Okay, okay. Second story created. First story cannot created. Okay, go and create again. Okay. Ah, first story created. Okay. Okay, go and see the story. I like and go and see the story. I think created. Okay. Okay, good. This one close. Okay. Now Analytica model created, right? So if you want to change, you can do more the further changes, right? So I think we don't got much time. Okay. Now I am going to export back, right? So what we want to do is we had to go Tekla integration, integrator for Tekla designer. Next, right? Now, first time I am going to export, right? Click export first time, click, right? So I want to export NTM model. So I exporting NTM model. So now you see automatically recognize, right? So I click yes. So now I had to select, I had to provide a um, new uh, file name. So this one I call at uh, rabbit to TST. TST. Maybe I can call 5A. Last time also give the same name. Okay. Okay. Closed. So I minimize this one. Go back to Tekla Success Designer. Okay. Here is a two things you can. First one you can update the model, or uh, you can create as a new file. Okay. So first I write to create a new as a new file, then we write to update it, right? So I close this one, save it and close it. So I open a new file. Okay, click new. Just create the new files. Right now I go to beam integration, structural beam imports. Okay, now select the file. So we call 5A Revit to CST, right? So select this one, right? Okay, next. First time, now we are first time importing because it's a new file. First time imports, right? Okay. So metric size, Euro code you can change to UK, right? Default level, right? What we choose is TOF, that means top of floor, right? So next, see, these are the elements we are importing. Okay, this one, okay. Okay, now look at the 3D model, right? So the changes, right? We have done the changes, so let's go and see the changes. Okay, the beam changes already captured. See this alignment change, right? Alignment change already captured, right? So let's go and see the plan. See this slab is there, right? Second story slab is there. Third story slab is there. Okay, the roof also there's a slab. Why there's a new levels? Wow, wow. Oh, I think we have changed the levels, right? That's why it's created a new level. So I think we don't need here. We can delete there. Oh, so let me see the one of the frame, then we can understand. Okay. You remember last time there's a 1 meter below this floor, right? That's why there's a level, right? So if we don't want, we can go to the here and we can delete this one. Select this one, right? Delete. Okay. So basically, okay. Okay, so even we updated our become export back to this analysis software yeah, after modify the model. So we can do the analysis now here, right? This is one way to do it. Another way is right also like just importing, right? Another way is I can open the existing file and update it. I open the existing file. This one, the class 6 file. So for to be integration imports. Select the file class file where Revit to DST, right? Next, update, level, next, 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 finish. Okay, so now it's updated, right? Updated, right? So say now we can in the Tekla second designer there's a one option that is quite powerful. We can see which are the elements updated, which are the elements deleted, which are the elements are new, right? So in order to see that, you have to go to review menu, Mm. right? So there's an option called beam status. Select the beam status. Now look at the color code, right? Look at the color code. So the slab all are new, important. The reason is, you remember we have modified the slab, we have joined the slab, right? That's why it's so as a new, right? In the yellow mean updated. You remember we update these slabs. Sorry, the beam. Remember we change the levels, right? We update this beam, right? So it's yellow, but um, but this beam we did not touch, right? Floor level beam, this floor slab we never touch it, right? So it's so as a not modified, right? It's not modified. Okay. The wall also we updated, right? So it's so as updated. Okay, this one also show as updater, right? That okay, foundation sometimes misleading because foundation they are not supporting quite well. Okay, this one reason maybe we lower down the levels. That's maybe a one reason. Sometimes it show as up important. I don't know the reasons. Sometimes it's happening. I don't know the exact reason. But this time I believe the reason is we change the level. Okay. So now you see you can easily understand, right? So in case we delete something, right? Sun is so as a red, then you can understand. Yeah, this element was deleted, right? So yeah, after imported, you can see what are the elements are updated, what are the elements are new. So you can, if you want to do the new design, then you can go and just design that element. You don't need to redesign all the elements. Okay, so this is very powerful. Similarly, after export, after change this one, after you export it Revit, you can see same thing in the Revit also. I think I can explain to you next time. The Revit is not easy. There's no any straight away option. You have to do some new, you have to create some new tools. Then you can see it. Then that's what I can explain to you later on, right? So now you understand how to export a Revit and how to export back to a, Tekla Saxena Designer, right? Not just a new model. You can update the existing model, right? So if you create a new model, the problem is loading. You can import the loading because Revit you don't create keep the loading information, right? So if you expand, if you import as a new file, then you don't see the loadings. Then you have to create a new loading. But if you import as a existing, that means if you update the model, then you can see the loading. You have all loading, right? So just update only the changes, right? Other area, you don't touch it. Then you can keep your loading. Right? So if you want, you can validate. Okay, always right after import, right? You have to validate the model. Sometimes it's got issue. You see, there's an issue. So let's see what's happened. Right? Uh, the slab not okay. The basically the slab. Okay, I think there's some issues that we can go and pick up this one. The slab not support. I think some changes in this here, so we had to adjust this one. Right? Right? What is the issue here? Member not supported. Okay, so it's showing which are the area we have the problem. Then we can go and see what's the issue. Then we can update that one. Okay, okay. I think that's all today. We can bind up here. If you have any question, then you can ask me. Anybody has any question? Okay, if you don't get the question right, then I can stop here. But I suggest you all of you to go back and practice yourself. At least you can start to model the example building, right? So okay, the member sizes, you don't bother with the member sizes. You can assume something and start the modeling, right? At least you can learn what are the issues, right? So select some member sizes, right? It may be wrong, no problem, right? So select some member sizes and go to the Revit and do the modeling in the Revit. Then export to Tekla Structure Designer and validate and see is there any problem or not, right? Or other way, start the modeling Tekla Structure and do the design, then export to Revit and see in the is there any issues in the integration process or not, right? That's why only you can learn it, right? Just attending the class may not enough to learn, right? So because the software, if you want to learn the software, you should have a hands-on experience. Okay, so if you have any doubts, you can write to me. I have share my email address. You can write to me. So I write to reply ASAP. So in case I cannot reply right, then end of the class I can answer your questions. Okay. Okay, that's all today. I finish it today. So see you again Tuesday. Okay, see you. Bye.